This video is about solving equations containing rational expressions. So again, we're solving rational equations. This time we're going to have one fraction being equal to another fraction, and when you have that happening, you can solve it by using cross multiplication. So we're going to take a look at a couple of examples here. Our first example, x minus 3 over 7 equals x plus 4 over 3. So we have two fractions that are equal to one another, and so we can cross multiply. So we can multiply the top of one fraction to the bottom of the other fraction. So we will take 3 times x minus 3. That's taking the numerator of the first fraction times the denominator of the second fraction. And then we'll take 7 times x plus 4. And these would be equal to each other then. Distribute the 3. We get 3x minus 9 equals, distributing the 7 gives us 7x plus 28. I'm going to subtract 7x from both sides. That gives me negative 4x minus 9 equals 28. And then we're going to add 9 to both sides, giving me negative 4x equals 37. And then we divide by negative 4. And we get x is equal to negative 37 fourths. And you don't need to write this as an improper fraction. Sorry, you don't need to rewrite this improper fraction as a mixed number. You can leave it just like this if you want. Also remember, when we're solving rational equations, we need to go back and just do a quick check. There aren't any x's in the denominators, and so this solution will be okay for this one. Our next equation, x plus 10 over x minus 5 equals 9 over 5 minus x. Again, we can cross multiply. That will give you 5 minus x times x plus 10. And that would be equal to 9 times x minus 5 when we cross multiply the other way. Now we're going to have to do FOIL over here. 5 times x is 5x. 5 times 10 is 50. Negative x times x is negative x squared. And negative x times 10 is negative 10x. Distribute the 9. So that's going to be equal to 9x minus 45. This is a quadratic, so we'll need everything on one side of the equation. First, I'm going to gather up my like terms, though. I have negative x squared. And then I have 5x and negative 10x. That's negative 5x and plus 50. That's equal to 9x minus 45. We really want this x squared to be positive, so I'm going to move all of these terms over with the 9x and the negative 49. So I'm going to add x squared, add 5x, and subtract 50 from both sides. So we have x squared, 9x and 5x is 14x. Negative 45 and negative 50 is negative 95. And set that equal to 0. So now we need to try to factor negative 95 so that the sum will give us 14. And 95, divide that by 5. And we get 19. So this will be x plus 19 times x minus 5. Set x plus 19 equal to 0. We would subtract 19 from both sides. Oops, I don't need an equal sign there. And we get x equals negative 19. Then you can set x minus 5 equal to 0. Add 5 to both sides. And you get x equals 5. Now, when we go back and do our visual check, when we plug this, excuse me, x equals 5 into our equation, notice we would have 5 minus 5, which is 0. And here we would also have 5 minus 5, which is 0. So this solution does not work. The only solution that will work here is the x equals negative 19. And also notice that in the very beginning we had x minus 5 and 5 minus x. Those are very similar. We could factor the negative 1 out of the 5 minus x. We've done this several times now. And if we do that, then we would have x plus 10 over x minus 5 equals 9 over negative 1. And remember, when we factor a negative 1 out, it changes the order of the subtraction, so that would be x minus 5 then. Now the denominators are the same. We could move this negative 1 up to the top. And so we would have x plus 10 over x minus 5 equals negative 9 over x minus 5. And when you have denominators that are the same on both sides of an equation, you can just solve the equation from the numerator. And so x plus 10 is equal to negative 9. You can subtract the 10 from both sides, and you get x equals negative 19. Same solution that we came up with before. This way is a little bit less work. Sometimes people will catch that, sometimes they won't. Either way, you'll end up with the correct answer. This way is just a little bit shorter. In this next example, it doesn't look like we could use cross multiplication at first, but we really can. This denominator factors as 2 times the quantity x minus 4. And we have a 4 up on top, so we could cancel. That would give us 4 over x minus 4. 2 goes into the 4 twice, so we have plus 2 over x minus 4 equals 6. Now we can add these two together since they have the same denominators. It would be 4 plus 2, which is 6, over x minus 4. And we can write this 6 as a fraction also. We can write it as 6 over 1. And then we could use the cross multiplication method if we wanted. So we would have 6 times x minus 4 equals 6. Again, there are two ways to go about solving this, and I'll just write this down again so that we can do it in both ways for you. The first way would be to distribute the 6, giving you 6x minus 24 equals 6. Add the 24 to both sides. That gives you 6x equals 30, and then divide by 6 on both sides, and you get x is equal to 5. The other way would be to divide both sides by 6. These 6's cancel, and we get x minus 4, and 6 divided by 6 is 1, and then add 4 to both sides, and we get x is equal to 5. So again, either way we come up with the same answer. It's just a matter of which you prefer doing. Again, on this next example, it doesn't look like we could use cross multiplication, but because these two fractions have the same denominator, we could actually combine them. And so we could subtract x over x minus 7 from both sides. And so we would have 6 over here on the left, and we could write that as a fraction, 6 over 1. And then that would be equal to, now that we have the same denominators, we can go ahead and do this subtraction. So 7 minus x over x minus 7. Go ahead and cross multiply. 1 times 7 minus x is 7 minus x. And 6 times x minus 7. We can't divide by the 6 on both sides because this 7 minus x is not divisible by the 6, so we don't have a choice but to distribute here. We have 7 minus x equals 6x minus 42. And we're going to add x to both sides. That gives me 7 equals 7x minus 42. And then we have to add 42 to both sides. We have 49 equals 7x, and the last step is to divide by 7. That gives me x is equal to 7. Now again, you have to go back and do a visual check. We have x equals 7 here, but our denominators are x minus 7, and so that will cause us to divide by 0, and so the answer is no solution. That ends our lecture on solving rational equations by cross-multiplying.